All right, guys. So this is a little strange. Hopefully it looks a little strange at first because you recognize that this says 9.4 and we're in chapter 8. But if you look at the title for 9.4, it's solved by factoring. So it makes perfect sense, and I think a lot more sense actually, if we do this while we're factoring. We're in that factoring mindset. So it's just a quick warm up, right? Here's a trinomial, can I factor it? So what's step one? Any single time I'm doing a factoring problem, well, look for GCF. There's no number in front of x squared, so I can't take a number out, right? So 1, right? Which means nothing happens. And let's see, they don't all have an x. Can't take out an x, so no GCF. Okay. Is it the difference of two squares? Because I have that on the brain from yesterday, right? Well, I don't think so, because that falls apart almost immediately in the fact that this is a trinomial, right? So that's a binomial, difference of two squares. But I don't see a number out in front, so this should be a simple trinomial. I should be able to go right to my double bubble, x and x. Now, what am I looking for to fill in the rest of that? This is a while ago that I did this, right? So let me run through this again. Let me think about it. What numbers are going to go here? When I multiply them, I'm going to have to get a positive 30. So they need to multiply to 30. And that 30 is positive, which means they're also going to add to negative 11. So I need to think of all the factors of 30, right? 1 and 30, 2 and 15, 3 and 10, and 5 and 6. And I need to think about if any of those can also add to negative 11. And I think I found the winner with 5 and 6. So I put a 5 and a 6, doesn't matter where, because so far my double bubbles, they both look the same. Signage, right? What's happening plus and minus? I'm so confused with difference of two squares on the brain again. Okay, all right, let me think about this. Multiplies to a positive. They must be the same. But when I add them, when I combine like terms, I have to get a negative 11 as a result. So they're both negative. Let me think about that and check my answer and make sure it makes sense, right? Negative 5 times negative 6, positive 30. Negative 5 plus negative 6, negative 11. I think we done good. All right. That's my answer. Great. So now, how does example 1 differ from my warm-up? Hopefully it looks super familiar and very, very similar to what we just did. What's the only difference? This equals 0 on the end. You know how you guys love to say no solution? Well, now you can actually say no solution because look, the directions say solve, and this is an equation. There is an equal sign. So we do have no solution back in the mix as an option, right? How is this going to change what we're doing? It's really not. So you're factoring exactly like you've been factoring the entire chapter. And it's really important to keep in mind. Students often struggle with this section, and I'm always so curious as to why, because the actual factoring part is a review. This is a review for your test. This is how do I factor any and every problem that's thrown at me. I know what to go through, GCF, right? Can I go straight to a double bubble? Maybe I have to do the rainbow. Maybe it's the difference of two squares. All that's changing is what happens after I factor. So I already know how to factor this. I just did it in my warm-up. It's right here. It's x minus 5, x minus 6. So I'm going to write that. X minus 5, x minus 6. But I can't lose this equals 0. I have to continue to write that every step of the way. This is still an equation. So what does this mean now? Let me think about this. I factored, right? So this is exactly what I've been doing all chapter. But now I'm asked to solve, which means they're looking for something like x equals 2, right? That's the end goal. X equals a number. So let me think about what I have here. I have two factors, right? What does that mean? Two things being multiplied. These two items, x minus 5 and x minus 6, these two quantities are going to be multiplied together. And that result of multiplying those two things is going to be 0. Okay? So if I multiply two things and that result is 0, what does that tell me about those two things? One of them has to be 0. Maybe they both are, but at least one of those is 0. So either this set of parentheses is a 0 once I plug in x, which means I get 0 times I don't care. 0 times anything is 0. Maybe this set of parentheses is going to result in a 0 once I plug in a certain number for x. And then I'd have something, I don't care what, times 0, and that would equal 0. So I'm going under this thought process. Okay, here's what I'm going with. One of these two factors, either the x minus 5 or the x minus 6, is equal to 0. One of these individual little pieces, factors, is itself 0, and that's why the multiplication results in 0. So now what do I have when I write this down, when I go with this logic, is I have these two tiny little easy peasy equations to solve, right? I wish we were still in chapter 2 solving these equations. How do I do that? Well, I undo what's happening to x, right? And whatever I do to one side, I have to do to the other. So solve for x. What does x equal? It's either 5 or it's 6. If I go back to my original equation and I plug in 5, my left-hand side will result in 0. If I go back to my original equation and I plug in 6, this whole thing on the left of my equal sign will equal 0. So either x is 5 or 6. And we're going to be sophisticated like we know we are, and we're going to write this in the sophisticated way. You ready to write some curly brackets, some braces? We're going to write solution sets. Either x is 5 or 6. This is how I write my solution set. That's your answer as a solution set. What is that solution set saying? What am I reporting as my answer? Well, x is either 5 or 6. It's one of the values from that set. And again, if you want to check, let's think about this. If I plug in 5 squared minus 11 times 5 plus 30 equals 0. Let's see if this checks out. 5 squared is 25. Minus 11 times 5 is 55 plus 30. Okay. What is 25 minus 55? Negative 30 plus 30. What is negative 30 plus 30? Well, that's 0. Oh my goodness. It checks out. Same thing would happen if I plugged in 6. Again, don't believe me? Let's try it. 6 squared minus 11 times 6. Plus 30. 36 minus 66 plus 30 equals 0. 36 minus 66, that's a negative 30 plus 30. 0 equals 0. It checks out. Let's try another one. You know how that first one always goes super slow, right? So I'm confused by it because I don't even remember how I started the problem. So example 2, let me take a look. All right, it's set equal to 0, big whoop. I know how to factor this, right? So I have, let's see, let's run through it. GCF, I don't think so. Difference of two squares, no. Simple trinomial, no number in front. I can go straight to my double bubble. Don't lose that equals 0. It's not all of a sudden an expression. It's an equation every single step of the way. X and X, what am I looking for? Two numbers that multiply to 26 and have a difference of 11. What are my factors of 26? 1 and 26, 2 and 13. That's all she wrote. So of those two pairs, does either pair have a difference of 11? Yes, 2 and 13. Put them wherever. This is all review. This is factoring. We've done this already. This has nothing to do with section 9.4 yet, except for the fact that I wrote equals 0. That's the only thing that makes it different. Let's see, multiplies to a negative means one's going to be a plus, one's going to be a minus. But when I combine like terms, I'm going to get a positive 11. That 13's got to be my positive guy because he's going to take over to give me that positive result. I have now factored. I've done the chapter 8 part. Now this is an equation where I have two things that are being multiplied and set equal to 0. So what does that mean? It means one of these two things is 0 itself. So either the x minus 2 part is equal to 0 or the x plus 13 part is equal to 0. Little tiny equations to solve that I can do in my sleep, right? Because this is chapter 2. I get two answers. I write it as a fancy solution set. If you want to be super fancy, write the smaller number first. I'm not going to hold you to that. Just get both numbers in that solution set. Something to just notice where students are often going to struggle. They get those numbers in, they factor, and then they want to take a shortcut and they want to jump right to the end. So what do? They see, oh, -2 and positive 13. That's my answer. But notice your answer. Look at the sign change. Because when you pull that expression out and set it equal to 0, you get the opposite sign once you solve. So please be careful. You do not want to jump right from here to your solution set step. You will make a mistake, especially because they're going to get more complicated, like in example 3. Factor. Don't worry about that equals 0. Pretend it's not there. Factor like you know how. Okay. No GCF. Not a binomial. Not of the difference of two squares. Can't go right to the double bubble. It's a complex trinomial. Why? It has the 5 in front. I got to rainbow this. -15. Multiplies to 15. And has a difference of 2. 3 and 5 are our winners. Different signs because they're going to multiply to be a negative. They're going to combine, when I combine like terms, they're going to result in a -2. So that 5 is going to get my negative. +3 minus 5 is going to give me a -2. So I am replacing -2x with a +3x and a -5x. And I now have a polynomial with 4 terms, and I'm going to factor by grouping. What's my GCF of my first 2 terms? Just an x. I'm left with 5x plus 3. This is section 8.6, factoring complex trinomials. What is my only thing in common for my second 2 terms in -1? Make sure you write that negative. 5x plus 3. I see that thing repeat. That makes me excited. I write my GCFs in one bubble. I write the thing that repeated in the other. And I still have my equals 0 because this is an equation and I'm solving. So all of that factoring that I just did is all section 8.6. No different. But now I have 2 things multiplied together that result in a 0. I'm going to set each individual item equal to 0, and I'm going to solve these equations. Now, when you have a complex trinomial, you're also going to have a more complicated little equation to solve. And if you don't write those steps out, you are probably going to make little mistakes. I love fractions, right? Love writing my answer as a fraction. -3/5. It's a beautiful thing. I absolutely love it. Do not try to go right from this step to the brackets.